This is the Heriot-Watts University Edinburgh campus, and it is absolutely stunning. But why does it need trail? Robbie Fraser, the man who proposed the project, is here to tell you.
Hello, I'm Robbie Fraser. I'm the Landscape Operations Manager at Heriot-Watts University. The original campus tree trail was on an A4 folded pamphlet with sort of limited information on it, so I felt it needed modernised and updated. So we've increased the number of trees on the trail, so we now have 50 trees on that, and I've given Ruaridh the information for each individual tree. The ecology of the campus is very important. I think it's important for the students and staff and also visitors to the campus from the surrounding communities.
So, let's discuss the main aims of this project. Primarily, it is to develop a usable, effective tour guide application to inform users about trees on the Heriot-Watts University Edinburgh campus. The application should also be a PWA and installable. The user should be able to navigate a virtual map to see trees around Edinburgh, as well as undertake a physical tour for the trees on campus. The tour should make use of QR, spatial triggering and speech synthesis technologies. In order to evaluate the system, an in-depth usability study should take place. This project is Trail, a mobile app for learning about trees on the Heriot-Watts University Edinburgh campus. Take Ben here. Ben wants to learn about this tree on campus. Using Trail, he can do so via spatial triggering, scanning a QR code, using the augmented reality system, or simply the user interface. This will then show Ben the tree information, as well as speak it aloud via speech synthesis and vibrate his device. Let's talk about how Trail works. The front end of the system is developed using HTML, CSS, JavaScript and Bootstrap, with JavaScript providing most of the functionality. The back end is written in Go, which is used for all page route handling, performing back-end queries and connections to the database, which is PostgreSQL with the PostGIS extension installed. GitHub is used for version control, as well as keeping any backups of the source code. A platform called Heroku is used for hosting both the database and the application. It's linked to GitHub, so whenever something is pushed, it senses this and deploys the application. The user then interacts with the front-end application in the form of post and get requests, providing the system with their current location and other such data. User input is very important for Trail's functionality. Let's talk about the application interface. The home screen boasts a dynamic welcome greeting, as well as some randomized tree facts and some useful campus phone numbers. The desktop version is similar with some added graphs. The tour page displays a map with the user's current location as a red arrow. The blue route line shows the trail path, and numbered tree icons demonstrate the trees. The map page allows users to explore trees across Edinburgh, which are represented by clusters. The scan page is where a user can either choose to scan a QR code or use the augmented reality system. A cool feature about Trail is that it's a PWA. This means it met the requirements of being served over HTTPS, having a web manifest file, and a service worker that lets the application work offline. This allows it to be installable, as shown here, and run natively like an app. A main achievement of the Trail application is that trees can be triggered spatially and the information read aloud via speech synthesis. Here's the demo of the spatial triggering system in action.
Tree 1, Hungarian oak. This Quercus frainetto is distinctively different from the common oak. They can grow up to 30 meters, 125 feet, tall. A wonderfully shaped tree to have outside the main entrance to the university.
The ability to scan QR codes right from the app is a huge achievement for Trail. This is shown here. Augmented reality is also an extremely exciting feature of Trail, although it was deemed to be a little unreliable. This application was then evaluated with 13 different participants, each one undertaking a pre-questionnaire, a task questionnaire, and a post-task questionnaire. Let's look at some of the demographics results. Majority of participants were under the age of 24. There is no result data for anyone over 45. 83% of participants had an iOS device, which is notable as it was found that iOS has some severe limitations. Browser preference results show that users tend to lean to the default browser installed on their device. Users were asked whether they would be comfortable testing physical aspects of the application like spatial triggering. 62% stated yes, but 92% were not near the test area. Let's look at how the tasks were performed. The first task asked a user to scan a QR code. The results demonstrate that users found the process extremely easy, rating the system with an average of 9.23 out of 10. A more negative response was yielded when users were asked to locate tree 1 on the map page. This result is primarily skewed due to the large Edinburgh tree dataset causing lag to the map page. Beginning a tour was evidently an extremely easy process. Users also found it extremely clear where their current location was. The most negative response was yielded when users were asked to add the application to their device's home screen. It is no coincidence that the more negative responses are those with iOS devices. This is because iOS does not have an automatic install prompt, whereas Android does. Onto the post questionnaire. The user interface was highly praised, with no score lower than an 8. Participants were then asked an open-ended question about what they would improve about the application. Many of them brought up the addition of instructions to add to home screen, as well as reducing the frequency of the lost pop-up. Participants were then given the opportunity to leave any additional comments or feedback. Some users stated they did not recognise the QR icon, as well as some lag on the map, but overall, the usability study was a great success, showing that the application is effective. While proven to be effective, there are still a variety of key limitations discovered throughout development. The PWA cache does not clear automatically, so there is scope that a user could be using an old version of the application. There's also no capacity to run the application's features while the device screen is locked. In terms of positioning, location accuracy in urban environments can be extremely volatile, and also if a user loses signal or connection, location cannot be obtained. Because of the volatility of location accuracy, it is possible that you could trigger a tree further ahead or behind where you actually are. This can result in confusion. Speech synthesis can sometimes be telling the user about tree 1 when in reality they have already traversed to tree 2. iOS does also not support automatic playing of speech, and it's kind of limited to the monotone characteristics of a computerized voice. As pointed out by participants in the evaluation study, the map interface is extremely slow, even though clustering was meant to improve this. Clustering also prevented the ability to click on specific Edinburgh trees. Some future work will now be proposed. To prevent triggering incorrect trees, nearby trees could be grouped together and a summary of this data could be triggered. UI and QR code scanning could then be used to get the specific tree data. As uncovered by the evaluation, instructions on how to install the PWA will be added to the home screen, as well as labels under the menu icons, and the lost pop-up will also reduce in frequency. Because the application is intended to be used on campus, it would be valuable for the university to obtain statistical data of the tours, for example, how long each user spends inside a geofence.
Thank you so much for watching my video. This project has provided me with invaluable start-to-finish software development experience.